Have you ever heard about the explosion or a radius blast that has left you in shock or gave your body goosebumps or a wave of current? No, I'm not talking about nuclear atomic bomb or any kind of missile. I'm talking about supernova, the biggest explosion that humans have ever seen. Each blast is the extremely bright, super powerful explosion of a star and several times more massive than the sun. A supernova is an explosion of a star at the end of its life, a dying star. It can emit more energy in a few seconds than our sun will radiate in its lifetime of billions of years. In other words, a supernova is what happens when a star has reached the end of its life and explodes in a brilliant burst of light. Supernovas can briefly outshine entire galaxies and radiate more energy than our sun will in its entire lifetime. This event marks the destruction of a star and results in the ejection of most of its material into space. A supernova can be divided into further types. In case of type 1, these lacks hydrogen lines in their spectra and results from the thermonuclear explosion of a white dwarf in a binary system. And in case of type 2, these show hydrogen lines in their spectra and result from the core collapse of massive stars, at least 8 times the mass of a sun. The colossal explosion of a star. Scientists have identified several types of supernova. Talking about the supernova type 2, the core collapse supernova occurs in the last stage of the life of the massive stars that are at least 8 times larger than our sun. And that is the thing we are actually going to focus on, and that led to the formation of black holes. So let's talk about black holes and how they are related to supernovas. Primordial black holes are thought to have formed in the early universe soon after the Big Bang. Stellar black holes form when the center of a very massive star collapses in upon itself. Exactly, you're right, we're talking about the supernovas. Big Bang, stellar explosion are actually the definition of supernova. So black holes are formed as a result of the supernova explosion. So let's dive deep into the fact how black holes are formed. So it involves the collapse of the massive stars, and here are some main ways black holes can form. Stellar collapse. When a star with a mass greater than about 20 to 25 times the mass of the sun exhausts its nuclear fuel, it undergoes a supernova explosion. Another type is neutron star mergers. When the two neutron stars in a binary system merge, the resulting mass can exceed the limit of the neutron star stability, leading to the formation of the black hole. Some other ways that led to the formation of the black holes are the direct collapse of the massive stars, accretion, or black hole mergers. Let's sum up the whole process in a sentence. A very massive star runs out of the nuclear fuel, its life ends, and the star then explodes as a supernova. What remains is just a black hole, usually only a few times heavier than our sun since the explosion has blown much of the stellar material away. In short, no supernova, no black hole. Now you must be thinking that sun is also a star, what about it? So let me tell you if it undergoes supernova explosion and creates a black hole or not. So the fact is our sun isn't massive enough to trigger a stellar explosion called a supernova. When it dies, and it will never become a black hole either. As we have discussed already, in order to create a supernova, a star needs about 10 to 20 times the mass of our sun. So the answer is no. It's too small for that. The sun needs to be more massive to end its life as a black hole. So that was it about today's video. I have discussed all the related facts and some other minor things that seems to be related somehow to this video, like hypernova, nebula, and sun as red giant. We will discuss in the short videos. So thank you for watching. Kindly like, share, and subscribe, and see you till the next video.